Hey everybody, here is a short video of me doing the last problem from the class P notes that we didn't quite get to in class. So we're going to graph f of x equal to x cubed minus 3x squared over x squared minus 2x plus 1. And I think it's definitely in your benefit to factor things before you start doing all the work. It's good to have both versions. So if I factor from the top, I can factor on x squared and I'm left with an x minus 3. And the denominator factors as x minus 1 times x minus 1. Which is going to be x minus 1 squared. Often the factored version is better for finding the x things like the x-intercepts and the vertical asymptotes, whereas the unfactored version is better for finding the y things like the y-intercept and the horizontal or slant asymptotes. So let's start with the y-intercept. Let's set x equal to 0. We're going to get f of 0, and I'm going to plug it into this version here. I'm going to get 0 minus 0 over 0 minus 0 plus 1, 0 over 1, which is 0. Great. X-intercepts. You can set the whole thing equal to 0, but really you just want to set the bottom equal to 0. So, set the top equal to 0. Bottom is for vertical asymptotes. So I'm going to set this equal to 0, but really it's just going to be setting the factored top equal to 0. You could do it the unfactored top, but it's going to be nicer that way because then we can see, oh yeah, we're going to get x equal to 0 with a multiplicity of 2. We're going to get x equal to 3 with a multiplicity of 1, meaning we know it's going to bounce at 0 and cross at 3. Vertical asymptote or vertical asymptotes, right? There could be multiple vertical asymptotes. We set the denominator equal to 0. We're going to get x equal to positive 1. I will also point out, I should have turned that off. So I'll point out that the multiplicity here is 2, meaning that either you're going to have a vertical asymptote where both sides go up to positive infinity, or both sides go down in the same direction to negative infinity. Right? It's not an odd, so we don't get the opposite behavior like we do. And then finally, there isn't a horizontal asymptote because the degree on top is larger, but there is a slant asymptote because the degree on top is exactly 1 larger. So we have to do the polynomial division. X squared minus 2x plus 1 divided into x cubed minus 3x squared. You don't actually really need these last two terms, but I'm going to write them anyway so you can see. So let's see. What do you multiply by x squared to get x cubed? X, of course. X times x squared is x cubed. X times negative 2x is negative 2x squared. And x times 1 is x. Subtract. That minus that is 0. I'm not going to write it. Negative 3x squared plus, right, because it's minus and minus. So negative 3 plus 2 is going to be a negative 1x squared. And then 0 minus x is going to be minus x. Bring down the 0. What do you multiply by x squared to get negative x squared? Negative 1. And then we don't worry about the rest, right? You could say negative 1 times that is, I don't want to do this work. So stop right there. You got red pen. So y equal to x minus 1 is my slant asymptote. Now we're going to put it all together. Oh, I suppose we could do the number line. So number line, I don't think we really need it, but on the number line, we're going to put all of our x stuff. So we're going to put our x-intercepts of 0 and 3 and our vertical asymptote of 1. We know it's going to do this kind of deal. So if we pick a number larger than 3, like 4, and plug it into the factored form, because it's easier to see in the factored form, we plug in 4, 4 squared is positive, 4 minus 3 is positive, 4 minus 1 squared is positive, so the whole thing's positive. At 3, it's a multiplicity of 1, meaning it's going to cross. So we're going to cross from positive to negative. And it's going to do this kind of deal. And it's going to do like that. Or you could plug in a number like 1. If you plug in 1, 1 squared is positive, 1 minus 3 is negative. Oh, sorry, not 1. 1's a poor choice because we have a vertical asymptote at 1. Sorry. If you plugged in 2, 2 squared is positive, 2 minus 3 is negative, 2 minus 1 is positive. So it's a positive times a negative divided by a positive, which is negative. Over here on the other side of 1, well, we know the type of vertical asymptote means both sides should be down. So we know it should be negative over here because of the even multiplicity. But you can also check. You can plug in like 1/2 1/2 squared is positive, 1/2 minus 3 is negative, and 1/2 minus 1 is negative, but a negative number squared is positive. So it's still positive times a negative divided by a positive, which is negative overall. And then finally, on the other side of 0, it should change. No, it should bounce, right? Because 0 came from an even multiplicity. So we're expecting it to do this sort of deal and be negative over here as well. It is, right? If we pick a number less than 0, like -1, -1 squared is positive, -1 minus 3 is negative, -1 minus 1 is -2, squared is positive. So positive, negative, positive, the whole thing's negative. Great. So now we're going to actually try and draw the graph with the slant asymptote in it as well. Pretty good axis, if I do say so myself. Let's see. So I want 0, 1, and 3, and I want a y-intercept of 0 as well. Great. Vertical asymptote at +1. And since I know I'm going to have stuff down here, I'm going to label it up here so my label's not in the way. And then I have an x-intercept at 3. And then my slant asymptote is y equal to x minus 1. So that would go through the point 0, the y-intercept 0, -1, and the x-intercept 1, 0. It doesn't really matter at all where these asymptotes cross each other. They're just kind of guidelines. So we know it's only positive here, and then everywhere else is going to be negative. So it's going to do something like this. We're getting closer and closer to its slant asymptote as we move way out to the right. As we move back this way, I have to go, well, it's going to be negative. I have to go down towards negative infinity. Getting closer and closer to the vertical asymptote as we move further and further in and down. On the other side, it's also going to be going down. And now check this out. I'm going to have to go up and I'm going to have to touch that point right there, right? Because that's one of my intercepts. So I'm going to go touch that point and then bounce off it. So touch it. I'm going to cross my slant asymptote, which is perfectly allowed, bounce off, and then I can't just go any which way. I eventually have to get closer to this asymptote. You don't want to be like super straight towards it. You want to kind of smoothly go to it like that. I've probably drawn that a little, not perfectly, but you know what? It doesn't have to be perfect, but it shouldn't be jagged. So that's how you would totally graph the function f of x equal to x cubed minus 3x squared over x squared minus 2x plus 1. Vertical asymptote at 1, intercepts at 0 and 3, slant asymptote, which I should also label. You don't really have to label it on the graph. You should label it somewhere of y equals x minus 1. And that's what that would look like. If you're curious, you could find this point right here. You definitely do not need to. I do not recommend trying to find it, but if you really wanted to, you would find it by setting your function, all of this equal to x minus 1, and then solving for x. It's not worth your time. But if you did want to do it just because you're curious, you should get something between 0 and 1, which is interesting. But yeah, I wouldn't bother. It might be actually really hard to solve, so I wouldn't spend your time doing that. You've got better things to do. All right, I will see you all later.